So today's seminar speaker is Stewart Lowndes, who is from UC Santa Barbara at NCs, which and works on the Ocean Health Index. Julie did her PhD at Hopkins Marine Station in the Gilly lab, where she worked on squid and Humboldt squid migration and some other Humboldt squid things, so you can always talk to her about that. And she did her undergraduate at UCLA. I'm going from memory here. At UCLA. And yeah, let's welcome her with a round of applause. That was a terrible introduction.
No, so Patrick and I worked in the Gilly lab together for years, and it's kind of awesome to be giving this talk here because we learned how to code together in a very painful way. And I'm excited to be here to talk to you guys about how data science and open data science is totally empowering and does not have to be awful as you learn it. So it's very different from the way we learned it ourselves. But yeah, so I think what I'm going to talk about today has been totally game-changing for my science and my life, like in the way I think about problems. And so I'm really excited for you guys to get excited about the potential for data science in your own research, and for us to like change the culture of the way environmental science, marine science is done, because there's a lot of cool practices and tools that we can put towards our science. So yeah, we all are here because we love marine systems and marine life, and we've got all of these we've got this the amazing opportunity to be working here in Monterey Bay. And there's all these awesome questions that we have about marine animals and environments and interactions, and we want to understand these things and put them into practice, both if we're thinking about ecology or management or policy or whatever our interests are. But inevitably, we hit walls with data analysis. Data analysis is something that is really hard for us because we're often we don't have the skill sets or the mindset to deal with data. It's not something that's traditionally been in our core curriculum, and so we can feel like this, where you've got this huge task ahead of you, and you don't know how to handle it with the skill sets you have. But don't worry, because there are open data science tools and community that exist, and they're powerful and empowering. And yes, I am saying that these practices are like the force in terms of the way you'll feel like you have a superpower when you're dealing with your data, in terms of and how you can apply that to your marine science and anything beyond. And in carrying this analogy forward, some of the biggest obstacles in engaging with these tools and practices are that you don't even know they exist, and you don't have confidence that you can do it. In this example, Luke's biggest obstacle was not Vader; it was confidence in himself that he could figure out the Force, right? So this is, I really strongly believe that this stuff is, you're able to learn it if you have patience and practice, and you have the guidance of existing Jedis that are in the community, and they exist, and you can become one for other people as well. Okay, so to bring it to science a little bit, our Ocean Health Index story is something that is kind of the narration through our transition into using these tools. So the Ocean Health Index is, I'm not going to get into really what the methods are of this project, but it's a large project that was started through NCs, where I am now. It took about 4 years of a NC's working group to come together. It brought together ocean scientists, economists, oceanographers, trying to understand how to score how healthy oceans are so that we could bring more science into ocean management. So this is a multi-year effort. In 2012, it was published in Nature by Ben Halpern, who's currently still my boss at NC's, and a bunch of other co-authors. And we published the methods, and we also scored every single country in the world that has a coastline and said how healthy their oceans are. And we plan to do this repeatedly. So we plan to do this in 2012 for all the world's coastal countries and territories, and then repeat it. So we kind of set ourselves up thinking that we were going to be repeating this. So we took detailed notes of all of our data processing. We had somebody code up all of our scientific models, and we described them in 130 pages of supplemental material, like detailing all of the models that we used. And we shared all of our model data through an FTP site. And in 2012, this is quite beyond the norm, like the norm of how much information you shared when you publish stuff. And then we went to repeat it, and it was this huge reckoning where we realized that our approaches were totally inadequate, not because of the scientific models and the science that was coded, but because of the data science, because of all of our data preparation of 100 different data sources was done in Excel with names like this, like data final.xl, and we were pouring through our communications with each other to figure out, how columns had been reordered and subsetted and tabs, all of that stuff that goes with Excel. And these emails were in really cryptic subject lines, right? Re-forward, data question, maybe it doesn't have the attachment, all this stuff. And I like to say too that, I didn't break into your computers and steal these files from you, but I know they're there. This is the way we all work, and that's why I'm so empowered to tell you about how we got to where we are today, which is way better than we ever were. We now work totally transparently and repeatably. We've now repeated our study 7 times and made improvements along the way. And there's 20 other groups around the world, from the government of Colombia to the Stockholm Resilience Center, who are using not only our scientific method, but our code. And they are able to run our code, to tailor our code for their practices, and actually manage their oceans in this really transparent and scientific way. And this is what we just published in Nature, Ecology, and Evolution last year, was this whole journey that I'm going to be talking about today. Okay, so yeah, we learned that reproducibility in science requires reproducibility in data. And as a preview, instead of having those weird final.xls files, we now have a streamlined workflow where we code in open source languages like R in RStudio, and we use version control in GitHub. And I'm going to get you along this journey with us. But yeah, so we can take our data and our spatial file, like spatial or tabular data, into this workflow and have a really well communicated output at the end. Okay, the way we got here, there were 3 things that are really game-changing for us, and they're going to be for you too, and this is going to be kind of the theme throughout my talk, is the 3 things that are going to empower you and improve your science are to accept that data science is a discipline that can really help your science. The second is that there are tools that exist, open tools that exist to enable data science. And the third is that you can learn these tools, and you can learn them with your collaborators and with your community that we're going to redefine. So I'm going to walk through these 3 things kind of generally for you, and then I'm going to walk through them with the Ocean Health Index as an example, and then talk about exactly what you guys can do to not only ingrain this into the way you work, but also communicate it to others so that we can all work more efficiently and reproducibly. Okay, so the first thing is that data science is this superpower. It is a discipline that can help you for your science. There's a lot of different definitions of data science, but I like the one that is turning raw data into understanding. And it's a discipline, so that means that there's concepts to it, there's theory, and there's tools. So just the way chemistry has concepts, theories, and tools for the lab bench, data science is no different. And this will help you think about data and work with data. There's a big emphasis in data science to turn it into something that's easily communicated. Data science is also not just for big data. That's something you read about when you read about data science in the news. You hear about big data, you hear about machine learning, and that's very true. But most of data science is not machine learning and artificial intelligence and all that stuff. It's data munging. It's like moving spreadsheet columns around. Like that is actually data science as well. Something that I think is really important as a scientist to think about is that your study system, even though it's something that is very unique to what you're doing in science, the data that you're dealing with is not unique. So that you're wanting to move columns around and join two different data sets. Maybe it's from a temperature logger and scuba transects or something. Joining two data sets together, that is not something that's unique to your study system. That is a problem that data science has solutions for. So I think that having that expectation that your data challenges are not unique will help you find solutions faster. So this is something I really like about. So this is a workflow for data science, and you'll see Hadley Wickham's name throughout my talk. He wrote a book all about using R for data science, and that's where the quote's from, and this is also a visualization from this book. But so no matter what your study system is, no matter what your hypotheses are, no matter what your motivation is for doing your science, you're going to have to take your data and import it into something that you can analyze it with. Then you're going to need to tidy your data and get it into a structure so that you can start asking questions. And when you start asking questions, you're going to be kind of transforming your data, looking at certain years, looking at certain sites, certain species. You're going to be visualizing it, modeling it, really trying to understand like really get to ask your research questions. And ultimately, you'll be communicating your end results. And I think that this is something I can't emphasize enough, is that tidying your data is something that should happen first before you start answering your research questions. It will make your workflow make more sense to you, down the line, make sense to others. It's also much cleaner to not be trying to formulate your analyses around whatever weird format your data are in, or whatever weird format your collaborator wrote in as an Excel table. Like, you should take the time to make your data tidy so that this whole plethora of tools are available for a way to think about your data. So the reason why this stuff matters for science is that it'll really help you think deliberately about your data. And if you can distinguish your data questions from research questions, you'll be able to learn how to ask for help really soon. So for me, I studied, like Patrick said, I studied Humboldt squid over at Hopkins for my PhD. And I had a lot of trouble. I wanted to learn where Humboldt squid swam and what conditions they lived in. And those are questions that nobody had ever asked in California. Like, this was like at the edge of discovery. But me trying to rename my column headers in MATLAB was like, I roped that into this thing that had never been done before, like my squid migrations. And so I didn't know who to ask in order to find help for renaming columns, right? And so I wasted a lot of time. I couldn't format dates. I thought that was like a squid problem and not a data science problem. And I wasted a lot of time. And so being able to distinguish this is a big deal. The second one is that it will save a ton of heartache, like kind of what I just described. You don't need to reinvent the wheel. Somebody has renamed columns before in the history of analysis. And so you should learn how to ask that question and hear what the answers are. And the way you ask that question is you paste it into Google. You type it into Google or copy your error message and put it into Google. That will save a ton of heartache if you expect that this is something that somebody has encountered before. The third is that this will just save you a ton of time. If you expect that there's a better way to do it, it will give you more time to focus on the science. Instead of spending 2 months reformatting dates, I could have been looking at how migrations differed at different depths. I could have gotten there sooner, and if I wasn't focused on this small task that I thought no one had ever encountered before. So this will let you focus on the science. Okay, so the second one is that open data science tools exist. And this is also, so my talk is all going to be pretty focused on a single suite of tools that I use in my work. For example, R. But just like this lightsaber is just one tool that a Jedi can use, there are other languages, other things. There's Python, there's a lot of other different things. But one of the themes here, too, is that the Force is not dependent only on the tools, right? What you learn with one tool or one programming language will transfer to other languages, other problems in the future. Okay, so what are open data science tools? So data science is kind of a thing I made up. It's a mashup of open science and data science. But we've described data science to you, but what open science is it's a concept of transparency at all stages of the research process, coupled with free access to data, code, and papers. So open science is kind of a spectrum, and there's a lot of discussion in the scientific literature and online about moving more towards open science and open publishing. And having tools that will enable you to do your data science well, having them be open is like a bonus. And for me, all of the tools we use, like I can't distinguish where data science ends and open science begins, which is why I kind of made this mashup. But there are tools that will make your data analysis better, and as a bonus, they are open and shareable, which is really powerful. So these tools are not only just for data analysis and making your figures and everything, it's also really important and game-changing for collaboration and for communication. And I'm going to show you examples of all of this. And this is a big deal too. Like, these tools are created by, first of all, by people. It's not like a company and you will never, get help beyond Clippy or whatever. But they're developed by people, and they're developed by nice people, like people who you can reach out to on Twitter, on Facebook. You can email them, and they will respond to you. They will try to help you. They're building tools to make their science better, their research better, and they're putting it out there so that other people can take advantage as well. So you can talk to them, and that's a huge deal because we are social people, social animals, and learning together and being able to ask questions is a big part of moving forward. Okay, so some of the examples of the tools that are in my mind as I'm saying all of this is R and RStudio, but these are examples of open coding languages that have emerging shared practices, and so Python is another example of this. What I mean by open access is that you don't have to pay to get the software. It's I lost my MATLAB license when I left Stanford, and so I can't rerun my code from my thesis. So that is not an example of an open language. And then second of all, we use Git and GitHub. So this is essentially shared bookkeeping and organization for yourself and a team. And then it also has this component online in the cloud where you can also take advantage of free online display and distribution. So building websites and distributing your information and code. So another thing I think about when I think about open data science tools is specific packages in R that will enable you to do something. So this is a screenshot from Hadley Wickham's presentation last year where he's put specific packages in R that will let you do all the things on that workflow that I showed earlier. So to import, for example, is your data in Excel? There's a package for that. Is your data on a database? There's a package for that. Is it in SAS? There's a package for that. Is it in a database? And then is it in Google Sheets? Is it in a PDF? There's packages that will be able even, to scrape data from a PDF and get it in so that you're already in that import phase and ready for the tidying phase. So just trying to not reinvent the wheel and take advantage of existing tools is huge. So these are all packages in this figure right here. These are all packages made by RStudio in this kind of tidyverse universe where you're trying to get your data into a tidy format so that all of these analytical packages will then work based on your tidy data. And again, not on whatever weird format your data started off in before it was tidy. What's amazing too about GitHub is this will let person one, me, write an analysis on my own computer and then easily collaborate with person two over there on their own computer or across the world. And we'll be able to run each other's code, which is huge. Running each other's code has always been a nightmare based on file paths and dependencies, but GitHub will let you write each other's code, especially as you use more and more shared practices within R. So why this matters for science. Not only is it way more efficient to build off of these existing tools, but it gives you way more confidence in your own analyses moving forward. Having a traceable, reusable record is huge. And if it sort of sends chills down your spine to be asked to rerun an analysis you did a year ago or a few months ago even, depending on what it is, then these practices are really important to start ingraining into your work. My PhD advisor asked me to give him a figure for my thesis like 2 weeks ago, and it was embarrassing how long it took me to just find the PNG of the figure, or the PDF. Like, my file structure was all over the place. I didn't even know where to look. I had to use my Apple search thing and try to go by date. It was really embarrassing. So yeah, you'll save a lot of time. If you use the sort of automation capabilities within coding, that will help a lot. But especially if you think ahead of time, instead of just trying to get the job done right now, if you think that maybe you'll be asked to make this report monthly, and so maybe you'll set it up in a way that it will be easy to rerun later, or pre-thesis or pre-committee meeting and post-committee meeting, you're going to have to rerun this and build off of it. So maybe it would be easier to set it up ahead of time. It also saves you a ton of time with bookkeeping, like knowing what folders to save things in when somebody emails you a file. Like, how much of our lives do we spend organizing that and then finding that again? But if you have a shared bookkeeping session or setup in your file structure, it's great. And also convenient access. If you work openly online and use GitHub for some of these organizational things you're doing, for me it acts like an extended memory. I can remember a URL, or I can remember how to navigate to it, and that's where the information is. I don't have to keep things in my head as much. I should say too, I'm talking about R and GitHub mainly in my mind, but Google Drive is a huge example of the collaborative power of some of these tools, like in Dropbox too. And one of the reasons that we started using these tools is because we looked to see what Silicon Valley was doing. So these are the same tools that Airbnb uses to analyze how price fluctuations are going to happen, like in their internal team, or how Genentech looks at their clinical trial data internally. Like, these are tools that, like, other people who are sharing data and having to do analyses and report to each other, these are the tools they're using, and so that's why we started using them too. Okay, so the third one is you can learn these tools. I never thought I'd be able to learn these tools. You can ask Patrick about that, but I did, obviously, and the way to do this is to learn with community and collaborators. And we're going to redefine what that means, right? Because Luke obviously had to have an open mind about who his collaborators were going to be. And it was okay that not everybody was a Jedi that he was going to be collaborating with, and that's cool. So if you, we're going to redefine community and collaborators, but when you learn with others, especially in the coding sense, which is what this paper is, it helps overcome isolation, self-taught bad practices, and apprehension in engaging in coding and all of these data science practices. So when I think about collaborators, like, I immediately think of myself. Like, I am my most important collaborator. What I do now needs to make sense to me next month when I come back to this analysis. Where I put this thing, what I name it, has to make sense to me later. I will take the time to write documentation to myself to make sure that this will make sense to me later. And then I'll also put it on GitHub so I don't have to remember where it is. I can navigate to it. So future you is the most important collaborator you have. And past you does not respond to emails or help you at all. They are the worst. So be the best for your future self. In terms of community, like, think of community beyond scientists in our own field. Like, for me, reaching out to data scientists or archaeologists that I see using the same tools has been amazing, and I've learned so much from this one archaeologist. He's amazing, and the data that he's looking at is pretty similar to the data that ecologists collect, to be honest. It's sort of events that may not be able to be repeatable, but you try to learn as much as you can in this one circumstance and bring different, they're doing temperature loggers as they're digging cores and looking at all kinds of different middens and stuff. It's pretty cool, and I can learn a lot from the way that they operate in their data science spectrum. And the way you learn should be from others. It should be together with others, like in a physical space or online. It's great with beers. So I'm happy to talk about starting a coding club here or in Monterey Bay if you guys or anybody's interested. And I think also learning for others is really important. And this comes back to future you. Like, as you're learning something, write, something that's become kind of a common practice is to write a tutorial for yourself as you're learning something, and then as you're writing that for yourself, if you're planning to share that online, you start writing it for others beyond yourself as well. And then, so at UCSB, we started off learning within our own team at NCs, and then when people at UCSB heard about this, they started asking us, and so we started writing tutorials and do monthly skill sharing sessions where we either show something we're already working on, or if we want to learn something new, we'll take the time to write up a tutorial that then we'll teach people. So we're not experts in any of this stuff, but we know enough and are interested enough to skill share. And in my world too, this means a lot of existing communities that are there to help people learn how to code. No one is born learned how to code, and basically all the tools I just showed you so far have really gained traction in the last like 5 years, and some of them are still coming out every other day. So nobody knows this stuff yet, and getting together and learning with people is great. These are all sort of online communities that also meet in person, and I'm happy to I can talk about all these things in much more detail later on. So bringing this back to how this matters for your science. Learning to talk about your data with other people will help you get to solutions faster. Building confidence, this is huge, because all the skills you learn in data science are transferable beyond your scientific topic right now. And that gives you a kind of confidence as you're thinking about other projects that you're going to be working on in a way that has really changed my outlook on what I think is possible. And then also being empathetic and inclusive as you're learning these things, because everybody that you're around, even if they're not in your own discipline, will become your allies and a network. And that's a pretty powerful thing as well. Okay, so these are the 3 things again. So let's talk about how this relates to our Ocean Health Index story. Because we kind of felt like this in 2013. We had to like run and find something different like really quickly. And so one of the biggest things we did was, as we just embraced that data science was a thing that could help us, is that it's not a secret. This is coming out more and more that data preparation is huge. It can take 50 to 80% of the time before you can even get to your analysis. So it's really important to recognize that and to deal with that before you start getting into your research questions. This is another thing I can't emphasize enough. It's like tidying your data first instead of accommodating whatever messy data you have, really getting it tidy and then focusing on the analysis after that. We have deliberate shared practices, and we have meetings where we talk about file structure we're going to have, that we're going to talk about file naming, practices we're going to introduce, and maybe as we go, we decide that old one wasn't as good and we're going to redo it. This is kind of boring stuff, but it will save you a lot of time. And then we emphasize documentation and communication throughout. Like everything we write is for ourselves and for our team and for anyone else because it's all public. And so we've gone from, instead of having, we had 100 different data sets, some of which were spatial, like the shapefiles up at the top left, and some of them were tabular in a PDF. We came from, so we have 100 different data sources. We basically had like 50 different analytical approaches for all of these data sets. We were using, some of the time we were doing analyses in Excel, sometimes in R, sometimes Python, sometimes Bash, whatever. Now we do it all in R. So there's only, as new team members come, there's one thing for them to learn. We use RStudio to learn R, or to use R, because the interface is really helpful as you learn, and it's a shared practice, and they have a lot of those tools that I was talking about. And we use GitHub and Git to then be able to communicate in several different ways. So what this really means is that each of us on our own computer are really focused on reproducibility. We're coding, and we're using version control all on our own computer, and that's something that you can all do as well. We're using the tidyverse, and this is really the keystone of what we're doing. But then we use the cloud to share back and forth with communication, record keeping, file sharing, and then this big focus on communication. And this is all done with those 4 tools. And I will get to a demo and show this all to you, so I know I've said these things a couple times now. So this is what the RStudio interface looks like. There's it kind of looks like MATLAB to me. It was very comforting to me, instead of just using the R console, which is right here, which is if you've used R before, like I tried in grad school, and that's all it was, and that was kind of intimidating to me. But this is where you have your code and your scripts. There's also a nice place to explore your variables, but also connect to GitHub directly, so you don't have to have another software open to do that. And then there's also a place that you can see your plots and load packages. And so there's a lot of redundancy. If I don't know how to load a package in R yet, I can click to it and do it, and it will tell me the code that did that, so then I can learn. So there's a lot of, it's pretty welcoming to new users, which I think is amazing. And we're all new users because there's all new things that are coming up all the time, and it's pretty awesome. So then we use GitHub for record keeping and file sharing. And so this is a screenshot of github.com where it's showing us line by line what changed at a certain time. And so the familiar red is something that was deleted, green is something that was added. So it's really cool because the underlying version control, it kind of works. I think of this stuff as kind of like Dropbox, in that like things on your computer will be synced, but you have way more control about when that happens and what it happens, and you have to be really deliberate about it because it's looking line by line so that it can take my additions and Patrick's additions and weave them together so that neither of us are spending the time doing that. So it's super powerful. And it's also, I guess I covered this up a little bit so you can't see it, but it's also showing the differences between PNGs. That's pretty awesome. The color bar is different on the right, and so you can see that this is the same analysis, but the color bar has changed the way those petals look. And using GitHub to help you error check at a glance what's different between files is pretty powerful. So this is the way, instead of having Excel files that get really blurry between what's data and what's analysis, this is what our data, we keep our raw data raw, and we have our analysis in something that looks like this. So this is actually quite pleasing to look at. It is quite, it's formatted. There's sort of an idea of where the data came from and then what's going on. And then the code is right there along with all the figures that will come through the analysis as you sort of clean up data and explore it in terms of, until you get to your final data processing that you will use for something else. So we also use these GitHub and RStudio to make websites, and I'll actually click on some of these for us for a second so we can just have a look at them. So this is where all of our work is stored through github.com through our Ocean Health Index science username, and then this is essentially every folder that we have on our file, every project that we're working on is here, and you can see that people are working on it as we speak. 6 minutes ago there's been an update. But then also we made a website to outwardly communicate all of our scientific methods and our data science methods. And this website essentially was also made in R, and it's hosted for free on GitHub. So it's pretty powerful. You can make a website that looks pretty lovely without knowing anything about building websites. And also we've also started making books. I don't know how to make an online book, but our studio does, and so I can write. So we now lead 2-day trainings on how to do this stuff as well, which is pretty cool. Okay. But now we're gonna get to the live demo, which I've never done before. You guys are a guinea pig, but I think it will be pretty cool. So this is our studio. We're gonna do a little Moss Landing Marine Lab demo. What we're gonna do is I'm just gonna show you some data visualization and how to make a reproducible report in our Markdown. And then we're going to use the power of GitHub to make this a website. So right now, this is my file. It's this long. I'm actually paste in some code that I wrote a little bit earlier, but what we're gonna do is we're going to load a package, load some data, and then we're gonna explore. This is National Park Visitation in California. We're gonna explore park visitations through time in California. So what I'm gonna do, this is what the code looks like, and I'm gonna even say let's add a photo. So this is what the code looks like. It's a small file that's all in human English with some formatting and a little bit of code. And if I knit this thing, it's gonna produce a HTML file which is going to have a little bit more formatting in the text than we saw here, in terms of like, this is bold, and everything like that. But then also we're going to see our code nicely formatted. And then as we actually start plotting, we're going to see our plot right here in line. So if I wanted to do something like, yeah, and then we'll see the photo as well. So this is pretty cool. You can imagine, like, if you have a committee meeting, like, this would be kind of a nice report. Or at least I wish I had had this when I was in grad school. Okay, so that was a little. So this is an HTML that's just locally still on my computer, but I can use this this Git pane in our studio here. It's been watching this file, and it can see that all of this stuff we just added about the park visitation stuff is new, so it's green. So I'm going to, this window's a little weird because I've got it so small, hang on. But I'm going to say, these are the things that I want to sync online. I'm going to have to commit to this thing that I'm going to sync online, and then actually push it to the cloud. That's like there's a couple vocabulary words to learn, but okay, this is great. So I've pushed this to github.com, to my username, to my demo folder, and that's, so let's have a look at that. If we go to github.com, to my username, to the demo folder, I'll make this a little bigger. You can see this is where we are. At a glance, you can see that 31 seconds ago, something happened, and it was that Jules32 made this live demo. So that's pretty cool that this is now synced. You know, so right now, okay, so it's kind of like Dropbox, it's synced. You can see that just these files were synced. And you could actually look at, we'll inspect that file in a minute. But what's cool, too, is that this HTML file, if we look at it here, it's just going to be raw HTML code that I did not write, but that when I knit my file, it generated this HTML. I did not write this. I don't know how to write HTML. But if I look at this not through github.com, but through the free website that GitHub made for me when I made this user account, if I look at this, this is a website. This is something that I could share with collaborators and I'd feel really confident about, which is cool. And then there's no files that we're emailing back and forth. You send them one link, and you can see all of the stuff here. This is a URL that you guys can look at on your phones. This is like our analysis that we just did, which is pretty cool. So now let's say sorry, was there a question? Okay. Now let's say we also want to add a box plot. So I had, hang on, got my little cheat sheet here somewhere. Hang on. Oh, never mind. Let me see if I can bring it back. There it is, box plot. Okay, if I reknit this, now we'll add a new box plot. So now we not only see each park through time, but now we've got a nice box plot, and we could figure out how to deal with these labels later. But just for illustration, let's push this back to the cloud. Let's look at, oh, see, now it's only green, what I've just added. So it's tracking that. I write a little message to myself so that when I go back to figure out why I made this box plot, I'll remember that, oh, right, it was my live demo. And not like, you know, this insight that I had in the middle of the night. So let's go back now and go to this Jules32 demo thing. We can again see that we added the box plot live 20 seconds ago. And if we actually, the HTML file is not that interesting on github.com, but if we look here, we can see what's going on here. We'll even render the photo here. And I can look through time and see everything that's happened to this file, and I could jump back to it if I wanted to, which is pretty cool. Okay, let's go here and we'll refresh, and hopefully our box plot is online, which is great because it's what our collaborators wanted before the meeting, and boom, there it is. So it's pretty powerful stuff for communication and analyses and repeating what you've done and being able to walk backwards. Okay, so that went okay, which is great. Okay. Okay, so the third thing for the Ocean Health Index are these same community groups that I've talked about before. So I won't spend any more time, and I want to be conscious of time. But if we look at all three of these together now for the Ocean Health Index, all three of these things make our work more transparent and reproducible. And that makes it so that we can repeat each of our analyses every year, and it's quicker, faster, and cheaper because we can build off of what we've already got. And that actually has let us take less time. Yeah, so this is a graphical representation of what I just said. But every year, we've been able to focus more on different science questions based on how much data science we've put into it in previous years. So this is kind of showing that it's taken less time as time goes on, which are the size of the circles, and then whether we're focusing on science or data science in whatever given year. But what's the coolest thing about, so this is just for our teams. We've got a pretty small team actually, but it makes it look like we have a big impact. But what's even more important, I think, than us getting more efficient ourselves is that having this whole structure set up means that anybody in the world can do this for their own oceans, because that's the whole point of this, right? It's not to do all the cool data science things, although we love that, but it's to manage our oceans better. It's to get more science into ocean management. And so this is trying to show where all of our partners around the world are in terms of getting their local science and knowledge into their local management and policy. So they're able to take our structural architecture and our code and adapt it for their purposes, use their data, and get it into management. Okay, so that's our team. But I wanted to take a second to just talk about me personally, because I was really intimidated by learning how to code, and even, like, you don't even want to know the other things I considered instead of trying to learn how to do MATLAB. I was like, yeah, trying to use Excel like across different computers for the same thing, because my files were too big to open in Excel, so how could I do that? But, so I think it's just intimidating. And community was a huge part of getting me into this. I actually joined Twitter, which I never ever thought I would do, but it's because our developers are there, and they're talking about what needs to be done. They're building packages. They're like, oh, people are using Google Sheets more and more. Maybe they want to read that data directly into R. I'm making a package. Hey guys, does this work? Use it, see it, like tell me what to improve. It's pretty amazing. And so these communities are really welcoming just to non-computer scientists or stats people in general, but they're also really welcoming towards women and minorities, which is also awesome and has not always been in the culture of computing. The second thing I did to get into this is just try by doing it. Failing quickly, asking questions, writing up tutorials to myself, trying them out on other people, Googling errors, like actually copy-pasting errors into Google and not trying to describe them or interpret them, just paste them right in there. And yeah, starting to put down my thoughts and my struggles on websites and tutorials, partly as an extended memory, but also so that other people so that I can give back to the community. And a big part of that too is in teaching and skill sharing. And like I said, like none of us are experts in this yet, but you can help other people learn. And I learn, so I teach this stuff a lot now, and I learn all the time, not only from everybody's questions and how people think about it, but also from little tips that some people know that I have never heard of, and it's really great. So we've got a whole host of groups that we're involved in, whether they're informal in our lab or after work with beer or sponsored by like software carpentry and these more global networks, which is pretty cool. And I really think that this stuff made me a better scientist. It's really let me think differently about the scientific questions I can ask, like the scale of scientific questions I can ask, because I'm not moving these columns around all by myself. Learning all this stuff has also made me remember what it's like to learn something new. I think it's really easy for me to be like, oh, I know everything there is about Humboldt squid migration, but it's like, oh no, there's always something more to learn. And then, confidence. Like I've really gained confidence in myself that is transferable beyond my science, beyond data science, which is really important. And I've been actually moving away from doing my own marine research because I think this is so important to like enable everybody else. And so I think, I really want you guys to, feel like you want to be enabled and enable other people as well. So what you guys can do, so not everybody needs to run out here and learn how to code. Like that is not the way to do this. I really think a lot about team science and having shared practices within a lab or within collaborations or projects. And I think that we can all enable this culture of data science and open data science in the practices, even if you do not code. So knowing that it takes time and patience to learn this stuff, but that the payoff is great, is something that we can all instill in our labs and our culture, like the scientific cultures and our collaborations, even if we're not, downloading R on your phones right now. Yeah, so you can create community and you can join existing communities. So I think there's a lot of online communities that you can join, and for me that was making a Twitter account and seeing the R-Stats hashtag and who was talking on it and starting to follow them and seeing what they said. Like, that was the way I joined online communities. You can also, I just gave a software carpentry workshop at Imbari in December, and they were talking about starting like a coding club throughout Monterey Bay, and Hopkins was talking about that too. Like, I think we should make it happen. I don't know who, it can start off with having like beer with somebody and you both download R and GitHub together. Like, that is a success, but sort of making it fun, because it is fun and we should have fun with it. And there's a ton of online resources to make this possible. There's way too many to list. I've been terrible actually I've been trying to keep some lists updated, and they are totally out of date because there are so many great resources out there. But the ones that, so that this top link is actually, I think, really important. It's academic papers that talk about why this is important. So if you're having journal clubs in your lab, like, this could be a paper that you guys discuss, like just like the practices of and the importance of this stuff. And then also resources for actually learning it. So there's a ton of resources out there. These lists are just ones that like personally helped us to try to, I don't know, we can't keep track of everything, but there's a ton of other tutorials that are really great that I would love to have, like, add to a list. So that's on my to-do list, is making a list of awesome resources. And I think another thing is, if you are gonna learn, like, learn with intention. Yeah, do not learn in a panic by yourself only to get the job done, because that's the way I learned in MATLAB, and that is not the way to like change the culture and really take advantage of all the awesomeness that there is. Okay, so that's everything. I want you to remember these things so you can tell everybody you know. And yeah, I want to thank you guys all. Thanks. Yeah, so my slides are all online. There's links. And yeah, there's so much out there, but using YouTube as a resource, using podcasts as a resource to, I've listened to a podcast about spreadsheets, and I was like, I would never have thought this was interesting in my entire life. But having people think about deliberately about the way you would organize data and the way you would move from there is pretty cool. They'll become nerds really quickly. Yeah.
So if data science is the force, what's the dark side of the force?
Yeah. I mean, that's in the news more than the good stuff, isn't it? Like with Facebook and Trump. Yeah, no, definitely. But that means we need more examples of data science for good. That was actually a conversation on Twitter yesterday where they were like, what are examples of data science for good? And I was like, well, here's some from the marine realm that I know. That's, so let's add more. Yeah. Yeah, there's a lot of ethics involved with sharing data, and yeah.
So the whole Ocean Health Index, you said you're using about 100 data sets to go in that. How did you choose those, and what are the criteria associated with bringing those in?
That's a great idea. Great question. So we, the Ocean Health Index starts kind of like on a conceptual level, where we have 10 categories of things that humans think are important about the ocean. So that it provides food, that it provides protection from storms, that it provides jobs. So it's like social and economic and ecological as well. From those categories, at whatever scale we're doing the assessment, we look at what the best data available that's public and free. So at the global scale, we use fisheries data from FAO and the sea around us. We use World Bank data on tourism. So there's not a lot of standard oceanography data like I would have expected coming from more of an oceanography background, but it's much more geared towards the the data available at the scale that you're operating on. When this is done in Sweden, they're able to think about the better data they have at a smaller spatial resolution and use, county level data on water temperatures and stuff. So it's kind of this, one of the big problems with making a composite indicator, composite indicators was, do you make a list of all the things you wish were in it, or do you only base it on the data that you have? And either one of those will bias it a lot or make it impossible. And so we try to meet in the middle and always improve it. Every year we're trying to, if there's a better data source, we'll figure out how to put it in there.
And is there any weighting associated with the different sources, data sources? Information differently as it goes into the index?
Yes, there is on multiple levels. So within each of these 10 categories, the data are modeled to represent to represent the food provided to people. So that whatever the data sources are would be weighted differently in that model. But then each of those 10 categories can also be weighted differently. If we think that the food that the ocean provides is more important than the coastal protection in Sweden, that's true because they don't have big storms. So it's pretty flexible. And a lot of it also, I think one of the biggest things that the Ocean Health Index does that we don't really talk about is that it helps identify data gaps. It helps identify, this is not a good data set to represent this, but it's the best we have, then let's put a spotlight on the fact that it's not very good. Yeah. Yes?
Hi. That's a really great talk.
Okay.
Relying on open source platforms, do you have any recommendations for backing up, making sure your stuff is secure? Do you have concerns about longevity of these open source sites?
That's always a question, right? R might not be around in 20 years because every other language has not been around a long time. But I think that's why these tools are so transferable. And a language is only as strong as its community, and it's the people practicing it. It's the same with spoken languages. And so if I find it comforting that so many people use R and GitHub in these ways, because if those things change, they will be the ones that figure out the new system, and then we'll all be able to migrate over there. So that's not a great answer. I'm not, but I think there's a lot of people using it, and it's improving, and it will evolve, and we'll all evolve with it. Yeah. So yeah. Yeah.
I was wondering if you have any advice on how to deal with migrating scripts from different versions of code. Because I know that, I was struggling with Patrick the other day, but I've also dealt with trying to have a script that's in MATLAB 2007 or whatever and move it to 12 and then to 17. Have you done anything like that, and how do you organize it?
We can talk about this more later, but there are ways people are thinking about that a lot in terms of the version of R that this requires and the package versions that it uses and all this stuff. And there's things called Docker that you might want to look into that's creating a virtual container of the reality that your computer has right now, and it saves that entire thing so that everything can work on MATLAB 2007 right there in its own reality. So it takes a lot of setting up. I've actually never personally used it, but a ton of people are using it now. There's also things like continuous integration, like this thing called Travis, if you've ever heard of it. That's okay. It will run, every change you make to your code, it will remotely run it on a different cloud machine to make sure that you haven't broken anything. So there's and it would be able to tell if MATLAB 2018 broke your code or something. Yeah.
Well, if there's no more questions, let's thank Julie.
Yeah. Thanks, guys.